Let's take a look at a few examples from section 4.7. In this section, we look at something called L'Hopital's rule. This is a rule used to evaluate certain limits, provided that they meet certain criteria. And I think what you'll find is it can be very useful. It's a rather powerful rule, but we do need to be careful and not try to apply it in cases where it's not actually applicable. Let's look at this first one. We've got the limit as x approaches 1 of 4 cosine pi x divided by cosine pi x plus x. Okay. Now, the thing to notice about this limit is if we looked at that function and said, well, we're dealing with continuous functions there, we can just maybe substitute in 1 and perhaps that will give us our answer. Well, the problem is that if we attempt to do that, we get 0 over 0. We've run into that situation before, and I'm sure will recall that when you reach 0 over 0, which we call an indeterminate form, that does not mean that's the end of the problem. And that 0 over 0, of course, is not the answer, but we need to find some other means of evaluating that. Okay, and one example of something that we've used in the past to deal with that indeterminate form is to factor. That's not an option here, unfortunately. But if we were dealing with polynomials, then that would be probably the way to proceed, or a way to proceed. But now we have this new tool called L'Hopital's rule. And here's what it says. If you're getting that 0 over 0 indeterminate form, then the limit, if this limit exists, is going to be the same as the limit of the derivative of the numerator over the derivative of the denominator. Okay, and I'm not including the statement here in the video, but if you can refer back to 4.7 to see that precise statement of the theorem or of the rule. But again, it just involves taking the derivative of the numerator and taking the derivative of the denominator. If that new limit exists, then it equals the limit of the original expression. Okay. And notice, by the way, when we're taking that derivative, we're not applying the quotient rule, even though we are dealing with a quotient. We are taking the derivative of the numerator and we're taking the derivative of the denominator. Okay. And that's what I did here. This is an x. So we've got the limit as x approaches 1, again, of now the derivative of the original numerator over the derivative of the original denominator. And that one we can just substitute in 1. If we do so, we get negative 4 pi over 1 or just negative 4 pi. So that is the answer that we found using L'Hopital's rule. Okay, so as I said a short time ago when we started the video, a thing to be careful of is we don't want to start trying to apply this to examples where it doesn't apply. That's probably the biggest word of caution I would give you for this topic, because a lot of times what students will do is they'll see this rule and they'll say, gee, this is really useful, and it takes things that otherwise we would have no easy means of evaluating, and it gets us to an answer fairly quickly oftentimes. But if you try to apply it in cases where it doesn't meet those criteria, then it will give you the wrong answer, or it potentially will give you the wrong answer. And that would be the case here. Here, you're going through these L'Hopital's rule problems. You might take this and immediately go to the derivative of the numerator or the derivative of the denominator. that would give you the wrong answer here. The correct answer here we can get by simply substituting in 1. So if we just substitute in 1, we get 1 plus 2 over 1 plus 3. So we get 3/4. That's the limit. And that did not involve L'Hopital's rule whatsoever. And again, if we had tried to use L'Hopital's rule, it would give us a different answer. So be careful. Finally, let's look at number 41 here. This is the limit as x approaches 0 of x cosecant x. Okay, now looking at this one, this looks different than either of these other two examples that we talked about, because we're not taking the limit of a quotient. Or at least the way it's expressed here, it's not expressed as the limit of a quotient. And L'Hopital's rule is a rule that's stated for limits of quotients. However, it's worth keeping in mind that we could rewrite this as the limit as x approaches 0 of x over sine x. So it can be expressed as the limit of a quotient. And when written that way, L'Hopital's rule does apply. We do get that 0 over 0 form. And if we apply L'Hopital's rule, we're taking the limit as x approaches 0 of 1 over cosine x, which is 1. Okay? And so that gives us our answer. Okay, so again, just to kind of wrap up here, L'Hopital's rule can be a quite useful rule for evaluating limits. We do need to be careful not to try to apply it in cases where it does not apply, because it will give us the wrong answer, typically, if we do that. It can also be used for things that may not originally be given to us as a quotient. Okay, I hope that you found that helpful, and I will see you in the next video.